Before the breach, before all the headlines and the chaos, there's always something else happening first.
A quieter phase.
Yeah, this painstaking intelligence gathering.
Yeah.
It's like attackers drawing an invisible blueprint of their target.
Exactly. And they want to know everything about, say, your organization, or maybe even you, without you ever realizing they were even looking.
So our deep dive today is really a shortcut into understanding this world of footprinting and reconnaissance.
Right. This is the prep stage. It's where they gather as much knowledge as possible to build that complete security profile, that blueprint you mentioned.
Whether the target's a whole network, a single server, or maybe a key person inside a company.
Precisely.
And the sources we're digging into today, they come from structured curriculum, detailing the methods, the tools.
The objectives, yeah. It's the playbook for this initial phase, really. How attackers find that weakest link.
Okay, so to kick things off, we need to understand the two main types of this surveillance, right? Because it matters how traceable it is.
Absolutely. First up is passive footprinting. This is all about gathering intel without directly poking the target.
So observing from a distance.
Exactly. You're using public sources, open source intelligence, OSINT, no direct contact.
Okay, and the other type?
That's active footprinting. Now, this does involve direct interaction. You're actually sending packets, maybe scanning the network.
So you're potentially leaving digital footprints.
You are. It could elate the target that someone's probing them. It's definitely riskier for the attacker.
And the relevance for you, the listener, is kind of understanding this attacker blueprint, right?
Because if you get how they build it, you see that defense isn't just about firewalls. It's about vigilance across all your public data points, even the non-technical ones.
Okay, let's unpack that first part then, the passive stuff.
Yeah.
This gold mine of public data. How are attackers finding sensitive details just out there?
Well, often the main tool is something we all use every day, Google, but they use it with surgical precision.
You mean Google hacking or Google Dorking?
That's the one. They use these advanced search operators, the Dorks, to find very specific, often hidden information that, a normal search would just miss.
Can you give us an example? Like, how powerful can one query be?
Sure. Think about combining operators like filetype.pdf with site.onion and the word confidential.
Okay. So that's looking for PDFs.
Right, but not just any PDFs, specifically PDFs marked confidential that Google has somehow indexed, but only on darkweb.onion sites.
Yeah, so it bypasses all the noise
Yeah.
and goes straight for potentially leaked sensitive documents on the dark web.
Exactly. It targets sensitive stuff directly.
And I guess the security community has sort of cataloged these types of searches.
Oh, yeah. There's the Google Hacking Database, the GHDB. It's a huge collection of these dorks designed to find exposed files, misconfigurations, vulnerable devices.
But finding login pages accidentally left open? Or files with passwords?
Precisely that. Or even error messages that reveal too much, like specific software versions that have known vulnerabilities.
And our sources mentioned that this is getting faster, more efficient.
Definitely. Attackers are now using AI tools, things like Shell GPT, to automate and refine these dorking tasks.
So they can sift through massive amounts of data much quicker.
Finds the needles in the haystack way faster. Speed is crucial. But what if the data isn't on Google?
Right. What them?
That leads us to more specialized search engines. Think Shodan or Senses. People call them search engines for the Internet of Things, or just search engines for Internet devices.
Okay, so these aren't indexing web pages like Google. They're looking for actual hardware.
Exactly. Systems. They map devices connected to the Internet routers, servers, webcams, even industrial control systems, SCADA systems.
And what kind of info do they find on these devices?
Things like their geographic location, which ports are open, maybe the operating system details. If a company has, say, a vulnerable VPN endpoint or an exposed VoIP system,
Shodan or Senses will likely spot it.
Giving the attacker a direct vector to target.
So they map the current vulnerabilities. But you mentioned attackers also like digging into the past.
They absolutely do. History can be a surprisingly rich attack surface. The Internet Archive's Wayback Machine is a really potent tool here.
Oh, so, I mean, just old websites, right?
It's more than that. It archives web pages, sure, but also documents, images, sometimes even old software versions that were online years ago but got taken down.
Ah, I see. So if a company removed a document because it had say, sensitive configuration details or some legal issue.
It might still be findable on the Wayback Machine. It really drives home that on the internet, deleted doesn't always mean gone. It often just means archived.
An old internal memo accidentally posted 5 years ago.
Could still be out there, yeah.
Yeah.
Perfect fodder for phishing attacks or maybe revealing internal systems they thought were hidden.
Okay, so that brings us to connecting these broader searches to specific organizations and people. How does combining all these scattered bits of data create a profile useful for, say, social engineering?
Right. This is where it gets personal, potentially weaponizing the human element. You've got basic people search services like Spokio. They can pull up phone numbers, emails, maybe even court records on employees.
Standard background check stuff, maybe.
Sort of, but then comes the really counterintuitive part our sources highlight: job postings.
Wait, job ads. How can a job posting be a security risk? That sounds kind of nuts.
Think like an attacker. You want to understand the target's internal tech stack, their security setup.
Okay.
So you look at a job description for maybe a junior network admin or DevOps engineer. What does it list under required skills?
Specific technologies, like operating systems.
Exactly. Specific OS versions, maybe particular firewall brands like Cisco or Palo Alto, virtualization platforms, maybe even details about how their network is segmented.
Wow. So the HR department is unintentionally providing a technical roadmap for attackers.
Pretty much. For free. And once they have a name, maybe from that job ad or LinkedIn, they can use tools like Sherlock.
What does Sherlock do?
It takes a username and finds that person's profile across dozens of social media sites almost instantly. Builds a picture of their online life.
Okay, painting a fuller picture of the individual.
And then there's theHarvester. It scrapes publicly available email addresses associated with the company's domain,
Giving them a list of targets for phishing or maybe even brute force password attacks.
Precisely. High-value targets for social engineering.
Now, this search doesn't just stay on the regular web, does it? The deep web comes into play too.
It can, yeah. The deep web, which you typically access using the Tor browser for anonymity,
Right.
is where attackers might look for more sensitive, often already stolen or leaked data. They'd use specific queries to hunt for things like configuration files containing passwords, private keys, maybe medical records, or proprietary info like patents that have ended up on illicit forums.
That sounds incredibly risky, though, and illegal. Is that a common starting point, or more something they do after they already have a foothold? Or for really high-stakes targets?
It's definitely high risk, and often follows an initial, smaller breach, or yes, in cases of serious corporate espionage. But a more common and often overlooked path involves using legitimate business intelligence tools.
Competitive intelligence.
Exactly. Repurposing tools meant for business strategy. Think about financial filings from Edgy OER, or legal databases like LexisNexis, company profile databases like D&B Hoover's.
How would an attacker use those?
They use them to build a deep historical and organizational profile. When did the company start? Who are the key executives? What's their financial situation? This context makes any social engineering attempt much more believable, much more tailored.
That's a very patient, observation-based approach. Okay, let's shift gears now from gathering context to actively mapping the technical infrastructure. This moves us into active footprinting, right?
Correct. We're starting to interact, gently perhaps, but directly. A common first step is who's footprinting.
Looking up domain registration details.
Yep. Using public records from regional internet registries, RISCR, SHUARs, like ARN here in North America. You look up the domain name.
And find.
The registrant's name, administrative contacts, the registrar they used, creation and expiry dates, the name servers, DNS servers, responsible for the domain.
So potentially names, emails, phone numbers of people managing the technical side.
Potentially, yes. And you combine that with IP geolocation. Tools like IP2 location take an IP address.
Like one found from the WHO's or other scans.
Right. And maps it to a physical location, city, region, ISP. This helps correlate digital assets to real-world locations, useful for planning or even social engineering.
Okay, so we know who owns the domain and roughly where their servers might be. Next up is mapping the network using DNS. This is where it gets quite technical, isn't it?
It does. DNS footprinting is about extracting the domain name system records. You mentioned acronyms like A, MX, SOA, TXT records.
Yeah, break those down a bit. What are MX and TXT records really telling an attacker?
Good question. It's crucial. The A records map domain names to the core server IP addresses. Simple enough. The MX records mail exchange tell you exactly which server handles all the company's incoming email.
So a prime target for attacks.
Definitely. And TXT records are interesting because they often contain configuration data, like SPF or DKIM keys for email security, or sometimes verification codes that can reveal relationships with third-party services or security policies.
So they know where the main servers are, who handles email,
Yeah,
and tools like security trails or Fierce just automate grabbing all that DNS info.
exactly. They query the DNS servers and pull down all those public records efficiently.
Okay, once they have key IP addresses,
Yeah.
they want to see the path to those IPs, right? That's traceroute.
Precisely. Traceroute maps the journey data packets take across the internet from the attacker to the target.
But why does an attacker care about all the routers in between?
Because that path is the network perimeter, or at least shows the edge. Traceroute sends specific packets. ICMP is common, but could be TCP or UDP, and each hop or router along the way responds with its IP address.
Okay.
If you see certain IP blocks, or if the router's DNS names hint at specific vendors like Cisco, Juniper, Palo Alto.
You've just identified the brand of their edge firewalls or routers.
Exactly. You might find vulnerabilities associated with that specific hardware before you even send a single malicious packet directly to their main servers. Tools like NetScan Tools Pro or PingPlotter can automate and visualize this whole process.
That provides real architectural insight without being too noisy yet. Okay, finally, let's talk about extracting data from routine communications, like email.
Email tracking can be surprisingly detailed when someone uses tracking pixels or links in an email.
Like in marketing emails.
Yeah, or spear phishing emails. It monitors timestamps and records that can reveal the recipient's IP address, their geolocation, the type of device they used, OS, browser.
Even how long they looked at the email.
Sometimes, yes, the read duration. All valuable intel for tailoring the next stage of an attack, making phishing seem more legitimate.
But the real technical treasure trove is hidden in plain sight in the email header.
Absolutely. We usually ignore it. But analyzing the full email header is crucial for attackers. It contains the sender's details, sure, but critically, the IP address of the sending mail server and the entire path the email took through various servers to reach the recipient.
So you can trace its origin and path.
Collecting all that routing information, the server names, the IPs, it's often the final piece needed to connect all the dots from the reconnaissance phase and launch a really well-informed attack.
Wow. Okay, so this entire process, starting from just a simple Google search, maybe looking at job ads, using Shodan, checking the Wayback Machine, then Who's, DNS mapping, traceroute, analyzing email headers, it paints a really comprehensive, almost frightening picture of just how much data is out there.
It really does. The goal is to synthesize all that info, organizational, network, system, people data into that complete blueprint of security weaknesses.
All before they launch any kind of actual exploit.
Exactly. The objective isn't just data collection for its own sake. It's strategic. It's about building the attack plan, identifying that single weakest link, whether it's a vulnerable server, an outdated piece of software, or even a person susceptible to social engineering.
So defense really has to start the moment you realize that pretty much everything you put out there publicly could become part of their blueprint.
That's the core challenge.
Which leads us to the final thought for you, the listener. A challenge based on everything we've just discussed. If you had to defend your own organization against this kind of meticulous footprinting, where would you start?
Yeah, knowing that a leak could be as simple as a poorly worded job description or an old file forgotten on an archive site.
What single, maybe overlooked piece of public information about your company, your project, your team might be the easiest way for an attacker to get that first foothold?
Thinking about that is central to defense in this age where information is just everywhere.